In this video, I am going to discuss about basics of deep learning. Deep learning is a subfield of machine learning that uses artificial neural networks with multiple deep layers to learn complex patterns from data, much like the human brain. It enables digital systems to understand unstructured data, recognize images and speech, and make predictions without being explicitly programmed, driving many modern AI applications. What is deep learning? Deep learning is a specialized type of machine learning that uses artificial neural networks with multiple processing layers to learn complex patterns and features from large datasets, inspired by the human brain. These deep neural networks process data through layers, transforming inputs into increasingly abstract representations to perform tasks like image recognition, natural language processing, and speech recognition. How it works. Working process of deep learning can be summarized as shown below. Neural networks. Deep learning models use neural networks, which are inspired by the human brain. Multiple layers. These networks have multiple layers, input, hidden, and output, that process data. Each layer transforms the input data, extracting increasingly complex features. Weight adjustment. The connections between neurons have weights, which are adjusted during the training process to improve the network's ability to mimic desired behaviors. Pattern recognition. By learning from large datasets, these networks can identify patterns and relationships, even in unstructured data. Key features of deep learning can be explained below. Learning from examples. Instead of explicit rules, deep learning systems learn from examples to build knowledge and adapt their behavior. Handling unstructured data. Deep learning excels at processing complex and unlabeled data, such as images and text. Autonomous feature extraction. The layers automatically extract relevant features and characteristics from raw data, improving accuracy. Types of deep learning. There are many different types of deep learning models. Some of the most common types include convolutional neural networks, CNNs. CNNs are used for image recognition and processing. They are particularly good at identifying objects in images, even when those objects are partially obscured or distorted. Deep reinforcement learning. Deep reinforcement learning is used for robotics and game playing. It is a type of machine learning that allows an agent to learn how to behave in an environment by interacting with it and receiving rewards or punishments. Recurrent neural networks, RNNs. RNNs are used for natural language processing and speech recognition. They are particularly good at understanding the context of a sentence or phrase, and they can be used to generate text or translate languages. What are the benefits of using deep learning models? There are a number of benefits to using deep learning models, including can learn complex relationships between features in data. This can make them more powerful than traditional machine learning methods, and allow for more sophisticated data analysis. Large dataset training. This makes them very scalable, and able to learn from a wider range of experiences, potentially leading to more accurate predictions. Data-driven learning. DL models can learn in a data-driven way, requiring less human intervention to train them, increasing efficiency and scalability. These models learn from data that is constantly being generated, such as data from sensors or social media. Potential challenges of using deep learning models. Deep learning also has a number of possible challenges, including data requirements. Deep learning models require large amounts of data to learn from, making it more difficult to apply deep learning to problems where there is not a lot of data available. Overfitting. DL models may be prone to overfitting. This means that they can learn the noise in the data rather than the underlying relationships, leading to potentially poorer performance on new, unseen data. Bias. These models can potentially be biased, depending on the data that it's based on. This can lead to unfair or inaccurate predictions. It is important to take steps to mitigate bias in deep learning models. Comparison between machine learning and deep learning. It shows in the comparison chart for easy understanding and get better knowledge how to apply and use both of them as per requirement of project or task assigned to you. Main features cover in this chart such as definition, architecture, data type, feature engineering, data volume, hardware requirement, training time, human intervention, and interpretability. Some of real-world application in deep learning can be classified as follows. Healthcare. Deep learning aids in analyzing medical images, X-rays, MRIs, to detect diseases, accelerates drug discovery by analyzing molecular data, and helps develop personalized treatments. Manufacturing, algorithms can provide real-time insights for predictive maintenance, quality control, and enhancing overall operational productivity. Cybersecurity, deep learning improves threat detection by identifying new and previously unseen malware with higher accuracy and fewer false positives than traditional methods. Content generation, deep learning models can generate human-like text, write creative content, and even produce code. Robotics, deep learning helps robots understand their environment and perform tasks with greater autonomy, even in hazardous conditions. Entertainment, deep learning personalizes content recommendations on streaming platforms, tailoring experiences to individual user preferences. Future trends in deep learning covers many developments in the IT and AI industry. Some of main future trends can be described as shown below. TinyML, deep learning models are being designed to operate on low-power micro-devices like IoT devices and wearables, enabling on-device intelligence. Model compression, techniques such as quantization, pruning, and knowledge distillation reduce the size and computational demands of models without compromising performance, making them suitable for resource-constrained devices. Federated learning, this approach trains models across decentralized devices, preserving data privacy and reducing reliance on heavy data transmission. Open source tools, the development of accessible platforms and frameworks is democratizing deep learning, lowering the barrier to entry for more users and organizations. Ethical considerations and regulation, there is a growing emphasis on ethical AI usage and the implementation of stricter regulations to ensure responsibility and prevent misuse as deep learning becomes more integrated into society. I think you have got better understanding about deep learning, concepts, how it works, types of machine learning, benefits, risk, real-world application, future trends, etc. It helps to get better understanding about methods, tips, and steps in deep learning functions to cater the needs according to requirement of relevant task or field. If you like this video, please press subscribe button and many more educational and technical video you can see in the future. Thank you very much your attention.